Hey, champs of Examsnet. Welcome to the question series of Examsnet. Today we'll be solving UPSC NDA 2023 mathematics paper. You know, you're going to solve about 100 questions, 80 questions in this paper. You are well aware of the pattern. I hope you are already having a very good practice of it. And may this paper help you prepare even better. Students, before moving further, please do visit our website www.examsnet.com, where you will find not only this, but similar type of a variety of other entrance exam question papers as well for your practice. You can also download our app. The link is available in the description box. So let's start with today's paper. Here's question number 1, which is based on omega, that is the non-real cube root of 1. Now, if there is omega, then you have to find out the value of this given expression. Let's go. So first thing, you know, omega can be written as -1 plus iota root 3 upon 2. And one thing more, 1 plus omega square is equal to 1. So that means if I take the denominator over here, omega plus omega square is, sorry, this is equal to 0. This is equal to -1, right? So let's fill in. The given expression will become now 1 minus omega upon omega plus omega square can be written as 1 minus omega upon -1, which is equal to omega minus 1. So omega, this is the value, let's fill. You will have -1 plus iota root 3 upon 2 minus 1, which will give you -3 plus iota root 3 upon 2. Let's separate the real and the imaginary part. Root 3 by 2 iota. Now, if I find out the modulus of it, so this will be 1 minus omega upon omega plus omega square. This is actually equal to root of -3 by 2 square plus this. This is equal to 9 by 4 plus 3 by 4. That is equal to root of 3, right? Because 12 by 4, that is 3, 3 root upon 2. Sorry, not 2. 2 will be already cancelled. Okay, I'll solve it. So this is root 3. This is the answer to this question. Let's check. We have option A as the correct answer. Hope you got that. Next is question number 2. What is the number of 6-digit numbers that can be formed only by using 0, 1, 2, 3, 4, 5 each one? That means repetition is not allowed, and divisible by 6. So very first thing, we are given that you have to form, two things are given. You have to form a 6-digit number, right? First thing, it should be a 6-digit number, no repetition. Third is that it should be divisible by 6. Okay. So let's go with this further. Now there are 3 cases. See, what is the divisibility test of 6? The number should be divisible by 2. Divisibility test of 6 says the number should be divisible by 2 and it should be divisible by 3 both. Now, what is the divisibility test of 2? The number should be an even number, and 3 is sum of number of digits should be divisible by 3. Sum of number of digits should be divisible by 3. Right? Now, the given digits are 0, 1, 2, 3, 4, and 5. That means, see, I'm having 6 places. 1, 2, 3, 4, 5, 6. That means this place, the ones place, can have either a 0 or a 2 or a 4. So these 3 things are allowed over here, right? So let's go with each one. First is, if when the last place we put 0. So when at the last place we put a 0, this number will be 3, 4, 5, 6. So here is a 0, that is for sure. And out of the 6, I have 5 numbers left. Right? 0 is occupied over here. So this place can be filled up in 5 ways. This place can be filled up in 4 ways, 3 ways, 2, 1 way. That means, so at the first place, we choose any digit from the remaining 5 digits. So this is a possible combination. Now the total number of ways in this case, total number of ways is 5 into 4 into 3 into 2 into 1. That is equal to 120. Now, second case, when the last digit is 2. When the last digit is 2. So 1, 2, 3, 4, 5, 6. This digit is, this place is occupied by 2, that's for sure. Now, this first place can be filled up in 4 ways. Why 4 ways and not 5 ways? See, you can't have a 0 over here. 0 is simply not allowed at this place, because then the number will be a 5-digit number. Hope you got that. So that means 0 is not allowed. 2 is already taken up. I'm left with 4 digits. 1, 3, 4, 5. That means 4 ways. So here you can have 0 also. That means this one also can be filled up in 4 ways. What are the possible digits? 0, 1, 3, 4, and 1 will be used up over here. Okay. So leaving that 1, there are 4 possible digits which are can over here. And this one can be filled in 3 ways. This one can be filled up in 2 and 1 way. Okay. So what is the total number of ways? That is equal to 4 into 4 into 3 into 2 into 1. 96. Okay. Similarly, when the last digit is 4, digit is 4. So 1, 2, 3, 4, 5, 6. This is taken up by 4. And the same thing, you can't have a 0 over here, which means this place can be filled up in 4 ways. This one also can be filled up in 4 ways. This will be filled up in 3, 2, and 1 way. So the total number of ways will be given by 4 multiply 4, 3, 2, 1. That is equal to 96. So we got all the possible ways. That means overall total number of such numbers is 120, 96, and 96, which will give you a total of 312. So this is the answer to this question. Let's check with the options. 312 is option D. Hope you understood this. Let's move to the next question, number 3. Okay, what is a binary number equivalent of a decimal number? This question is a bit related to computers also. So I hope you know that in computers, all the numbers or the alphabets, whatever you put in the computer, they are first changed into the binary equivalents, and then it is processed upon by the computers. Now, you are given the decimal number 1011. This is having the base of 10. You have to convert it into the binary number. I don't know the binary number, but the base is 2 for that. And there's a simple procedure for doing so. Let's go. The given number is 1011. There is no other option. I'll just divide everything by 2. So dividing this by 2 gives me 505, leaving a remainder of 1, 2, 252, a remainder of 1. Okay, and then this, then 126, a remainder of 0. 63, remainder of 0. Then 31, remainder of 1. 15, 1. 7, 1. 3, 1, 2, 1, 1. So the binary equivalent will be given by, let's start from the back. 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 1, 1. Okay, so this is the binary equivalent of this number. Let's check with the options what we have. Okay, this is equal to the last one, C, D, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Actually, this is not the one. The reason is I'm having 5 ones over here. And here we are having 6 ones. So the answer is none of the above. Option E. Hope you got that. Next is question number 4. Let A be the matrix of order 3 by 3 and determinant of A is 4 if 2 adjoint 3A is equal to 2 raised to power alpha, B 3 raised to power beta. Then what is the value of alpha plus beta? Okay, so now pay attention to this question. You are given that A is a matrix of order 3 by 3, which gives you that n's value is 3. And one more thing, that determinant of A is equal to 4. Now you know one thing, since determinant of K into adjoint of MA is equal to K raised to power n, determinant of adjoint of MA, where you know n is the order of the matrix. Also, determinant of adjoint of MA is equal to determinant of M raised to power n minus 1 into adjoint of A. This is equal to M raised to power n minus 1 raised to power n into determinant of adjoint of A. Now, we also know that adjoint of A is equal to determinant of A raised to power n minus 1. Now, let's get back to our problem. In the question, let's get back. So, you are given that K into adjoint of M A is equal to K raised to power n into M raised to power n square minus n into determinant of A n minus 1. So, if I compare it with this one, determinant of 2 adjoint 3 minus A, 2 adjoint 3, it was 3A. So here M is equal to, okay, here M is equal to 3 and K is equal to 2, and we already know it's 3. So this expression will become 2 adjoint of 3A is equal to 2 raised to power 3. It's given 3, okay, into 3 raised to power n minus, this is 9 minus 3 into 4 raised to power 3 minus 1, which will give you 2 raised to power 3 into 3 raised to power 6 into 2 raised to power 4, right? Which will give you 2 raised to power 7 multiply 3 raised to power 6. If I compare this with 2 raised to power alpha into 3 raised to power beta, you will get the value of alpha to be equal to 7 and beta is 6. So alpha plus beta is equal to 13. This is the answer. Option B is the correct answer. Hope you got that. Let's move to the next question then. Question number 5. If alpha and beta are the distinct roots of this equation, then the value of this whole expression is, you are given that alpha and beta are the distinct roots, that means the separate roots of this equation. And looking at the equation, you know what are the roots of it? That means alpha is equal to, the roots for this equation will be given by 1 plus iota root 3 upon 2, and beta will be equal to 1 minus this. Right. Actually, this is equal to minus omega, and this is equal to minus omega square. Right. And also one thing, that 1 plus omega and omega square is equal to 0. Let's get back to this one. So here omega can be written as minus 1 minus root iota root 3 upon 2, that is equal to minus alpha, and omega square can be written as minus 1 plus iota root 3 upon 2, which is equal to minus beta. Now you are given, let's get back to our expression. First of all, let's solve it. Alpha raised to power 100 plus beta raised to power 100 whole divided by alpha raised to power 100 minus beta raised to power 100. I'll pick up the numerator only first. Okay. Yeah. So let's pick it up. Alpha is equal to minus omega raised to power 100 and beta is equal to minus omega square raised to power 100. So this can be written as omega raised to power, because the powers are even. So this will be omega raised to power 100 plus omega raised to power 200. This can be written as 3 into 33 plus 1 plus 3 into 63 plus 2. This can be written as, so this thing will be omega 3 into 33 multiplied by omega raised to power 1, omega 3 multiplies 66 omega square. This is equal to 1, this is equal to 1. Omega cube is equal to 1. So this will be omega plus omega square, which is nothing but minus 1. This thing, 1 plus omega square is equal to 0. Omega plus omega square will be equal to minus 1. Similarly, omega raised to power 100, alpha raised to power 100 minus beta raised to power 100 will give you omega minus omega square. Okay, the only difference is this is plus and this one is minus. So this is equal to, omega was equal to minus 1 by 2 minus iota root 3 upon 2 plus 1 by 2 minus omega iota root 3 by 2. So these two will cancel and you will have minus 2 root 3 iota upon 2, which will be minus this. Okay. Now let's divide 1 and 2. We had to do the same thing in the question. This is 1 and this is 2. Dividing 1 and 2. 1 by 2. So alpha raised to power 100 this is equal to minus 1 upon minus this. Minus minus will cancel and you will have this. So multiplying the numerator and denominator with iota, this will be minus iota upon root 3. Right? You had to find out the modulus of it. So modulus will be given by root of 0 plus minus 1 by root 3 whole square, which will be equal to 1 by 3 root or this thing. So I think we got our answer, 1 by root 3. This is option D as the correct answer. Hope you got that. Let's move to the next question. Question number 6. It says A and B are symmetric matrices of same order. Then which of the following is correct regarding AB minus BA? Its diagonal entries are equal but non-zero. the sum of non-diagonal entries is 0. So you have to select the correct answer using the code which is given below. All right. So we are not given anything, just the order of the two matrices is same. I'll choose the simplest one, that is a 2 by 2 matrix. So I'll assume A to be equal to A, B, C, D, and the B matrix be equal to, okay, these are the symmetric matrix, right? So this one will be A, B, B, C, and B will be equal to D, E, E, F. AB, the product of the two matrices, will be given by AD plus BE, AE plus BF, BD plus CE, and BE plus CF. Similarly, BA, so now it is in the reverse order. BA will be given by AD plus BE, DB plus EC, EA plus BF, and EB plus CF. Okay, so these are the two matrices. Let's do what we had to do in the question was difference between the two. Let's find out AB minus BA. So AB minus BA, let's go for this. These two will be 0, right? And BECF, these two will also be 0. CEBD, sorry, not F. There is no F actually. Question number 6. Let A and B be the symmetric matrices of the same order. Then which of the following is correct regarding AB minus BA? You are given A and B are symmetric matrices. A and B are symmetric matrices, which means, what do you mean by symmetric matrices? Hope you know. It means that A is equal to A transpose and B is equal to B transpose. That's why they are symmetric matrices. So to solve the question, I'll assume let it be any matrix. A will be written as A, B, B, D, and B can be written as A, B, B, C, let it be. And B can be written as D, E, E, F. Now let's find out AB. AB can be written as first row, first column. This will be AD plus BE, AE plus BF. Then BD plus CE, BE plus CF. Similarly, BA can be written as AD plus BE, DB plus CE. Then AE plus BF, BE plus CF. Now let's subtract both of them. You have to do AB minus BA. Let's go. So AB minus BA, this will be 0. Now this is AE plus BF minus DB plus CE. Then this is also, no, this is not 0. This is BD plus CE minus AE plus BF, and this is 0. Okay. Now notice one thing. See, AB minus BA is equal to 0. AE plus BF minus DB plus CE. And this can be written as, I'm taking minus common, AE plus BF minus DB plus CE. This is 0 as well. So they are not what? They are skew symmetric matrices, right? This is a skew symmetric matrix. So you can see over here the diagonal entries. What is this saying you? The diagonal entries are equal but non-zero. No, the diagonal entries over here. This is a diagonal entry and this is 0. No. Next is, this is false. Next one, the sum of non-diagonal entries is 0. So the sum of these entries, if I say these entries, the sum of them is of course 0. If you add both of them, you will get a 0. That means option, not option, statement 2 is correct. Hope you got that. Here, option B is the correct answer. Hope you understood this question. Let's move to the next question then. Question number 7. Consider the following statements in respect to square matrices A, B, C of order n. First statement says if AB is equal to AC, that means B is equal to C if A is non-singular. Let's pick up the first one. It's given AB is equal to AC. So if A is non-singular matrix, then if A is non-singular matrix, then A inverse exists. Okay. Now, pre-multiplying both the sides with A inverse. Now, pre-multiplying both sides by A inverse, we get A inverse into AB is equal to A inverse into AC, which gives you A inverse into A. This is equal to, this is A's identity matrix into B, identity matrix C, which simply means, you know one thing, A inverse is equal to identity matrix, which simply means B is equal to C. That means the statement 1 is true. Let's go with the second one. It says if Bx is equal to Cx for every column matrix X having n rows, then B is equal to C. Okay, let's start with the contradiction of it. So the second statement says you, then B is equal to C. Let's assume B and C to be some different matrices. So I'm assuming B to be A, B, C, D, and C to be some matrix E, F, G, H. And X to be, it's given it's a column matrix. So it is XY. Now everything is given to you having n rows. Okay, same rows. So this is it. Next is, let's do for Bx is equal to Cx. It's given. So B is equal to A, B, C, D, and X is X, Y. This is equal to E, F, G, H, X, Y. Let's do the multiplication of both the matrices. You will have AX plus BY, CX plus DY is equal to EX plus FY, GX plus HY. So here, that means if they are equal, there is no compulsion that B and C should be equal. For Bx is equal to Cx, B need not be equal to C. That means statement 2 is wrong. This one is wrong. So only one is true. Option A is the correct answer. Hope you understood this. Let's move to the next question, number 8. The system of linear equations, 3 linear equations are given to you. This, and this. Has which type of solution? Unique, infinitely many, no solution, or exactly 3 solutions. Let's write down the system of linear equations. It's x plus 2y plus z is equal to 4. 2x plus 4y plus 2z is equal to 8. 3x plus 6y plus 3z is equal to 10. So by the Cramer's rule, using Cramer's rule, let's find out the determinant. 1, 2, 1, 2, 4, 2, 3, 6, 3. So this is equal to, I'll take 2 common from this second one. 1, 2, 1, 1, 2, 1, 3, 6, 3. So the two rows are equal. That means the determinant is equal to 0. Let's go for the delta 1. So delta 1 is equal to determinant of, now this time it's 4 to 1, 8, 4, 2, and 10, 6, 3. Here what I have done, I have omitted this z portion. Z coefficients of z, I have omitted that. I have taken the right hand side and y and x. So this determinant, again, I'll take 2 common from here. This will be 4, 2, 1, 4, 2, 1, 10, 6, 3. 2 rows are equal. That means this determinant is also equal to 0. Right? Okay. So next, let's find out delta 2. Now this time I'll be eliminating the y coefficient. 1, 4, 1, 2, 8, 2, 3, 10, 3. So again, I'll take 2 common from here. 1, 4, 1, 1, 4, 1, 3, 10, 3. So this is equal to 0 again. That means we got everything like, wait. This is now delta 3 also. Now this time I'll be eliminating the x1. So I'll have 2, 1, 4, 4, 2, 8, and 6, 3, 10. Again, taking 2 common, you'll have 2, 1, 4, 2, 1, 4, and 6, 3, 10. 2 rows are equal. That means this is also equal to 0. So simply you got this thing. Delta is equal to delta 1, delta 2, delta 3. And this everything is equal to 0. Therefore, the system of linear equations will have infinite solutions. Infinite solutions. So that means we have option B as the correct answer. Hope you got that. Let's move to the next question then. Question number 9. Let Ax is equal to B be the system of 3 linear equations with 3 unknowns. X1 and X2 be 2 distinct solutions of if the combination Ax1 plus Bx2 is a solution of this equation which is given system of linear equations, then where A and B are real numbers, then which of the following is correct? Okay, so first thing, this is the solution. So let the given equation be Ax1 plus Bx2 is equal to x3, which gives you Ax1 plus Bx2 minus x3 is equal to 0. Since we know that for the vectors, we know that for vectors x1, x2, x3 till xn, their linear combination will be Ax1 plus A2x2, A1x1 plus A2x2 plus A3x3, so on till an xn. This is equal to 0, where A1, A2, A3 till an are all scalars. If that is true, then that means A1 plus A2 plus A3 till an is equal to 0. Then from the equation 1, this one, from this equation, from equation 1, in linear combination, we have ax1 plus bx2 minus x3 is equal to 0. Here the sum of the scalars, which is a plus b minus 1 is equal to 0, which gives you a plus b is equal to 1. So let's check with the options. A plus b is equal to 1 is option B. Hope you got that. Let's move to the next question, number 10. What is the sum of the roots of this equation? Matrix. So sum of the roots of this equation. Let's go for this. Let's write it down. 0, 0, x minus a, x minus b, 0, x plus b, x plus c, x minus c, 1. This is equal to 0. So now expanding along first column. We get, see, this is 0 and this is whole 0, like this is 0, 0. So I'll just write on 0 plus 0 plus x plus b. This is multiplied by x minus a, x minus c minus 0. This is equal to 0. So basically, if I'm multiplying x plus b, x minus a, x minus c is equal to 0. So that means x can be equal to either a or minus b or c. Therefore, what you had to find out? Sum of the roots. So let's add them. This will be a minus b plus c. This is the sum of the roots. Let's check with the options. A minus b plus c is option B. Hope you understood this. Let's move to the next question then. Question number 11. If 2 minus iota root 3 and where iota is equal to root of minus 1 is a root of this equation, then what is the value of a and b? Basically, in the question, you have to find out a and b and then we will simply add them. Okay. So one thing, if 2 minus iota root 3 is a root of this equation of x square plus ax plus b is equal to 0, then another root will be 2 plus this. Why is that? We know that for any if any complex, we know that if any complex number is a root of quadratic equation, then its conjugate will be another root. Conjugate will be another root. Okay, so we have the two roots as 2 minus iota root 3 and 2 plus iota root 3. Using that, let's frame the equations. You had x square, so this will be one equation will be 2 minus root 3 iota square plus a into 2 minus root 3 iota plus b is equal to 0. And the second one is 2 plus root 3 iota square plus a into 2 plus root 3 iota plus b is equal to 0. Let's open it. So you will have 4 plus b square. So this will be minus 3 minus 4 this plus 2a minus root 3a iota plus b is equal to 0. So you have here 1 minus this is root 3 iota 4 plus a plus 2a plus b is equal to 0. So this is the first equation. Yeah. And let's go open up this one also. This is 4 minus 3 plus 4 root 3 iota plus 2a plus root 3a iota plus b is equal to 0, which gives you 1 plus root 3 iota 4 plus this is a plus 2a plus b is equal to 0. So now this is, let this be number 1 and this be number 2. Subtracting 1 and 2. 1 and 2. So I'll just cancel out what things will be getting cancelled. Subtracting 1 and 2, you will get minus 8 iota root 3 minus 2a iota root 3 is equal to 0, which will give you a is equal to minus 4. Okay, if a is equal to minus 4, let's put in the value in any of the given equations, you will get the value of b. So put a is equal to minus 4 in equation 1. We will get 1 minus iota 4 root 3 minus 8 plus 4 iota root 3 plus b is equal to 0, which will give you b is equal to 7. In the question, you had to find out a plus b, which is equal to 3. So this is the answer to our question. Let's check with the options. We have option D as the correct answer. Hope you got this. Let's move to the next question then. Question number 12. If z is equal to 1 plus iota root 3 upon 1 minus iota root 3, where iota is equal to minus of root of minus 1, then you have to find out argument of z. All right. So you are given z is a complex number, which is 1 plus root 3 iota upon 1 minus root 3 iota. Let's rationalize it. So this will be 1 plus root 3 iota upon 1 plus root 3 iota, which will give you 1 plus root 3 iota square upon 1 minus root 3 iota square. This is equal to a square plus b square, which is 1 minus 3 actually, plus 2 ab upon 1 plus 3, which is equal to 4. So this will give you minus 2 plus 2 root 3 iota upon 4. That is equal to minus 1 by 2 plus root 3 iota upon 2. So looking at this, that means this complex number lies in the second quadrant. Now, this complex number lies in second quadrant, right? Therefore, argument of z is equal to pi minus theta. So here theta is equal to tan inverse y upon z. You know that. So y was equal to root 3 by 2. Let's write it down, upon minus 1 by 2, which is equal to minus of root 3, right? Tan inverse. Okay. So that means this is equal to pi by 3. Sorry, here is minus 3. This actually can be written as tan inverse of minus tan pi by 3. Now I have to get rid of this minus. I'll write it down as tan inverse tan pi minus pi by 3, which will be equal to tan inverse of tan 2 pi by 3, that is equal to 2 pi by 3. So the answer to the question is option B. Hope you got this. Let's move to the next question, number 13. A, B, C are in AP. Then what is this equal to? So you are given a matrix. Let's understand x plus 1, x plus 2, x plus 3, x plus 2, x plus 3, x plus 4, x plus A, x plus B, x plus 3. Let's perform some operations. Let's do R1. Let's change R1 into R2 minus R1. You will get 1, 1, 1, same, x plus 2, x plus 3, x plus 4, x plus a, b, and c. Now further, I'll change C1 into C2 minus C1 and C2, C3 minus C2. So let's perform these operations. You will get 0, 0, 1, 1, 1, x plus 4 and b minus a, c minus b, x plus c. Now expanding along R1, this is the first row. This will be 0. This is 0. Expanding along first row, you'll have 0 plus 0 plus 1 into c minus b plus a, which gives you a minus 2b plus c. Now it's given a, b, c are in AP. So since they are in AP, therefore, since a, this is equal to 0, since a, b, c are in AP, sorry, this is, therefore, a plus c is equal to 2b, right? So I'll come back to this one. This will be a plus c minus this. So 2b minus 2b, this is equal to 0. So the answer to the question is option B. Hope you understood. Next is question number 14. Log to the base x, a, comma, a raised to power x, and log x to the base b are in GP. Then x is equal to what? So you are given, let's write down log x, a, ax, and this. They are in GP. So they are in GP. That simply means that product of these two is equal to square of this. Log x, a, multiply log x, b is equal to this. So this can be written as log, sorry, here is b. Okay, I have written something wrong. So log b x is equal to a raised to power x whole square. So these two logs, they are in multiplication. This will be equivalent to log b a is equal to a raised to power x whole square. So log b a is equal to a raised to power 2x, right? Now taking log on both sides. You will have log of ba is equal to 2 will come up here. So this will be log a 2x log a. This is equal to log of log ba is equal to, since I hope you got this step right. How did I do this? Log m raised to power n is equal to n log m. Okay. So, okay. This whole divided by log a is equal to 2x. Or I'll take 2 also over here. This will be log of a into log of a, sorry. Question number 14. If log a to the base x, a raised to power x, and log x to the base b are in GP, then x is equal to what? So let's understand this. You have log a to the base x, a raised to power x, and log x to the base b, they are in GP. So if they are in GP, you know the product of the first and the third term is equal to square of the second, which simply means log a to the base x multiply log x to the base b is equal to a raised to power x whole square. Then since they are in the multiplication, so this can be written as log a to the base b is equal to this. So this is actually equal to, okay, fine. That's it. So now taking log on both sides. Both sides. You will have log of log a to the base b is equal to now 2 log a raised to power x. Further, log of log a to the base b is equal to 2x log a. I hope what I'm doing over here, you know this. Log of m raised to power n is equal to n into log m. So here x can be written as, here is a, sorry. So here x can be written as log of a upon to the base b upon 2 log a. Now I'll be using the formula log b upon log a is actually equal to log this. So using this equation will become x is equal to log a to the base b upon 2. All right. So let's check with the options. What we have. Option C is the correct answer. Hope you got this. Then let's move to the next question. Question number 15. If 2 raised to power 1 by c, 2 raised to power b upon bc, ac, 2 raised to power 1 by a are in GP, then which one of the following is correct? So since these three terms are in the GP, that means the product of the first and the second is equal to the square of the third. Product of the first and the third is equal to square of the second. So 2 raised to power 1 by c multiply 2 raised to power 1 by a is equal to 2 raised to power 2b upon AC. So, bases are same, powers will be added. This will be AC like this, and this is equal to 2 raised to power 2b upon AC. Now equating the bases are same, powers will also be same, which means A plus C upon AC is equal to 2b this. These two will get cancel and A plus C is equal to 2b. That simply means A, B, C are in GP. Sorry, AP. A, B, C are in AP, that is arithmetic progression. See, first and the third term, the sum of the first and the third term is equal to twice the second. That means they are in arithmetic progression. So let's check. A, B, C are in AP. Option A is the correct answer. Hope you got that. Let's move to the next question, number 16. The first and the second terms of an AP are this and this respectively. Nth term is the largest negative term. What is the value of n? Okay. So first thing, first term, that means T1 is equal to 5 by 2. This is also equal to A or A1, and A2 is given to you as 23 by 12. These are the first and the second terms. So you know one thing, A plus D is equal to the second term. A1 plus D is equal to A2. So 5 by 2 plus D is equal to 23 by 12, which gives you the value of D as 23 by 12 minus 5 by 2. That is equal to 12, 23 minus 13 minus 7 by 12. So we got the D. We know A1, that is 5 by 2. We got D minus 7 by 12. So third term, what do you have to find out? Nth term, which is the largest negative number. Okay, so A2 was 23 by 12. A3 will be equal to 23 by 12 minus 7 by 12. That is equal to this. So next A4, that is the fourth term, 16 by 12 minus 7 by 12, which is equal to 9 by 12. A5, 9 by 12 minus 7 by 12, that is 2 by 12. And A6 is equal to minus 5 by 12. So we got our first negative value, right? Since whatever the next values you will calculate, they are going to be the smaller negative numbers. See, I'll calculate A7. That will come out to be minus 12 upon 12, which is equal to minus 1. Of course, minus 5 by 12 is greater than minus 1. That means we were looking for the largest negative number. That is got to be the sixth term. Look at this one. Minus 5 by 12. This is the sixth term and this is the largest negative number because the further negative numbers will be smaller than this. Hope you got this. So option B is the correct answer. Is that clear? Let's move to the next question, number 17. For how many integral values of k, the equation x squared minus 4x plus k is equal to 0, where k is an integer, has real roots, and both of them lie in the interval of 0 to 5. So the given equation is x squared minus 4x plus k is equal to 0. They have the real roots. And you know, discriminant for the real roots, the discriminant is got to be greater than equal to 0. What is discriminant? Minus 4. B square minus 4ac is greater than equal to 0. What is b? Minus 4 square minus 4. A is 1. C is k is greater than equal to 0. 16 is greater than equal to 4k, or k is less than equal to 4. Right. So hence in the interval 0 to 5, there are 4 values. 0 to 5. There are 4 values which are less than equal to 4. That is 0, 1, 2, and 3. 4 actually. 5 values. Okay, sorry, no, 0 is not included over here. Okay, so there are 5 values of k, that is 1, 2, 3, 4, for which the equation will have real roots. Right, that means we have option B as the answer. Hope you got that. Let's move to the next question then. Question number 17. For how many integral values of k, the equation this, where k is an integer, has real roots, and both of them lie in the interval of 0 to 5. So this is the given equation, x squared minus 4x plus k is equal to 0. They want the real roots. It's not said that they should be equal or distinct. Nothing is said like that. So that means in this case, the discriminant for this should be greater than equal to 0. Right. The formula for discriminant, b square minus 4ac should be greater than equal to 0. B is minus 4 square 4, 1, k should be greater than equal to 0. 16 should be greater than equal to 4k, or k should be less than equal to, k should be less than equal to 4. Now, both of them lie in the interval of 0 to 5, open interval. That means 0 and 5 are not included. I can't have the 0 in this case. So the possible values for k will be 1, 2, 3, 4. So there are 4 possible values for the k. That means option B is the correct answer. Hope you got that. Next is question number 18. In an AP, the first term is x. Sum of n terms is 0. What is the sum of next m terms? AP, arithmetic progression. The first term, that is A, is given to you as x. Formula for the sum of n terms is given by n by 2 into 2a plus n minus 1 into d. So it is given sum of first n terms is 0. So 0 is equal to n by 2. First term is given to be x. So 2x plus n minus 1 into d. N can't be equal to 0. That means 2x plus n minus 1 into d is equal to 0, which gives you d is equal to minus 2x upon n minus 1. Or d is equal to 2x upon 1 minus n. Okay. Now, further, you have to find out the sum of next m terms. Next m terms, that means you have to find out the sum of m plus n terms, right? Next m terms will be given by next n terms sum will be given by Sm plus n minus Sn. And this will be m plus n by 2, 2x plus m plus n minus 1 into d. And this was equal to 0. So I'll just write down 0 over here. Correct. Next, this is m plus n by 2. Let's open it. 2x plus m into d plus n minus 1 into d. So this is equal to 2x plus n minus 1 d. This is equal to 0. So this can be written as m plus n by 2, 0 plus m into d. M plus n by 2, m into 2x upon 1 minus n. This 2 and 2 will cancel, and you will have mx into m plus n upon 1 minus n as the answer. Hope you got this. Let's check with the options. Mx, m plus n upon 1 minus n. So option B stands to be the correct answer. Hope you understood. Let's move to the next question, number 19. Consider the following statements. 25 factorial plus 1 is divisible by 26. Is it true or false? Let's go for this. Second one also, 6 factorial plus 1 is divisible by 7. Okay. So we'll solve this sum using the Wilson theorem. What does this theorem says to you? Wilson theorem says for any prime number p, this always divides p minus 1 factorial plus 1. Okay, so p always, if p is a prime number, then it always divides p minus 1 factorial plus 1. So in the first case, statement 1, it is given that 25 factorial plus 1 is divisible by 26. But according to the Wilson theorem, this should be a prime number, but 26 is not a prime number. So Wilson theorem cannot be applied on statement 1, which makes it incorrect. Second one, 6 factorial plus 1 is divisible by 7. That's absolutely correct, because 7 is a that satisfies both the conditions of the Wilson theorem. That first is 7 is a prime number, and 7 divides 7 minus 1 factorial, which is 6 plus 1. So that means statement 2 is absolutely correct, and 2 only is the option. Option B stands to be the correct answer. Hope you understood this. Next is question number 20. It says if z is a complex number such that z minus 1 upon z plus 1 is purely imaginary, that means the real part is missing, then the modulus of z is equal to what? So first of all, let's assume the z to be any complex number x plus iota y. Then z minus 1 upon z plus 1 will be given by z plus iota y minus 1 z x plus iota y plus 1. Now let's segregate the real and imaginary parts. You will have x minus 1 plus iota y, x plus 1 plus iota y. Now multiplying the numerator and the denominator by x plus 1 minus iota y, x plus 1 minus iota y. So this will make it x minus 1 into x plus 1 minus x minus 1 into y iota plus x plus 1 into y iota minus iota square y, whole divided by a square minus b square. So iota square is minus, this will make it plus y square. Okay, right. So this can be written as x square minus 1 minus x y iota plus y iota plus x y iota plus y iota plus y. This 2 will cancel, and in the denominator, you have it as x square plus y square plus 2x plus 1. I hope you are getting this. So let's segregate the real and the imaginary parts now. So here was y square, sorry. This will be x square plus y square minus 1 plus y iota whole divided by x square plus y square plus 2x plus 1, which makes it x square plus y square minus 1 upon x square plus y square plus 2x minus plus 1 plus y iota upon x square plus y square plus 2x plus 1. Now, in the question says that this expression is purely imaginary. It is said it is purely imaginary, which means the real part is equal to 0. That makes x square plus y square minus 1 upon x square plus y square plus 2x plus 1 is equal to 0, which makes x square plus y square is equal to 1. Correct. So, see one thing more. If I'm saying z was equal to x plus iota y, so modulus of z can be written as root of x square plus y square. But this is equal to 1. So 1 square, 1. That means modulus of z is equal to 1. Let's see with the options. We have option C as the correct answer. Hope you got this. Next is question number 21. How many real numbers satisfy this given equation? X modulus of x minus 4 plus modulus of x minus 7 is equal to 15. Okay, so we actually have three cases in the question. First case, when x is greater than equal to 7. Then this whole equation will become x minus 4 plus x minus 7 is equal to 15. 2x is equal to 26 or x is equal to 13. All right, so second case. When x is less than equal to 4. So when x is less than equal to 4, this will become 4 minus x plus 7 minus x is equal to 15, which will make 11 minus 2x is equal to 15, or minus 4, this will be x is equal to minus 2. Okay, so let's name it as 1, as 2. So the third case, when x lies between 4 and 7. X lies between 4 and 7. Then the equation becomes x minus 4 plus 7 minus x is equal to 15, which is not an equation because x will get cancelled, which will not be an equation. Therefore, this has no solution. Hence, there are only two real numbers which satisfies the this equation, and we have option B as the correct answer. Hope you got this. Let's move to the next question. Question number 22. A mapping f from A to B defined as fx is equal to this equation where x belongs to A. If f is to be on to on, then what are the possible, what are A and B equal to? First of all, you need to understand what is the onto function. I hope you know this. Let's discuss it once again. So it says if A and B are two sets, then for every element of B, there exists one or more than one element matching with the set A. So if there are these three elements, then for every element of B, there exists an element in A. This is an onto function. And one for that, codomain is equal to range for onto functions. Let's get back to our sum now. You were given that fx is equal to 2x plus 3 upon 3 x plus 5. Now, for a function to be well defined, this should not be equal to 0. That means x should not be equal to minus 5 by 3. correct? That is domain of the function should not contain x is equal to minus 5 by 3. That means this domain of the function a will contain all the real numbers except minus 5 by 3. Okay, so I think we are done with quite a thing now, but minus 5 by 3 is present in option A and D. Let's work on the rest of the sum now. Now, since the function is on to, we already talked about it that codomain is equal to range. Let y is equal to fx, say, which was equal to 2x plus 3 upon 3x plus 5. This was equal to y. Do the cross multiplication. 3xy plus 5y is equal to 2x plus 3, which gives you, let's take the x common. So it will be 3y minus 2 is equal to 3 minus 5y, or x is equal to 3 minus 5y upon 3y minus 2, right? So that means now you can't have this equal to 0, which means y cannot be equal to 2 by 3, correct? So that means we will not have a pre-image of 2 by 3. 2 by 3 is not allowed to come in the domain, the codomain, okay? So therefore, B should have all the real numbers except 2 by 3 for the function to be well defined and to be well defined and onto as well. So that means we have two conditions, that real numbers should not contain 2 by 3 for the set B, and for set A, they cannot contain, set A will not contain minus 5 by 3. So set A will not contain minus 5 by 3 is this, and this is the correct answer, because here is minus 2 by 3, which makes option D to be the correct answer. Hope you understood this. Let's move to the next question then, 23. Alpha and beta be two distinct real roots of the quadratic equation x squared plus ax plus b is equal to 0. Which of the following statements is or are sufficient to find alpha? So if alpha and beta are the two roots of this equation, you know the sum of the roots is equal to minus b upon a. So here is b is actually, or you can say sum of the roots is equal to minus the coefficient of x divided by the coefficient of y square, which makes alpha plus beta is equal to minus a. And product of the roots is equal to the constant divided by coefficient of x square, which makes it b. Okay. Now, first says, if alpha plus beta is equal to 0 and alpha square plus beta square is equal to 2, is it sufficient to find out alpha? Let's do this thing. Alpha plus beta whole square. This can be written as alpha square plus beta square plus 2 alpha beta. This is equal to 0. We are given. This is equal to alpha square plus beta square. Okay, this is given to you 2 as well. 2 plus 2 into b. Okay, which makes b is equal to minus 1. So I'll not say, don't go for this because I need to find out alpha beta now. So I will just stop here only to alpha beta, which makes alpha beta is equal to minus 1. But we need to find out alpha only. Let's go for the second statement. It says alpha beta square is equal to minus 1. We know alpha beta is equal to minus 1. So minus 1 into beta is equal to minus 1, which makes beta is equal to 1. So if we got the beta, we can find out alpha also, because alpha into beta is equal to minus 1, which makes alpha into 1 is equal to minus 1. That means alpha is equal to 1. So clearly I used both the statements to find out the value of alpha, which means I need both of them to find out the value. Option C is the correct answer. Hope you got that. Let's move to the next question, number 24. If the sixth term in the binomial expansion of this is 5600, then what is the value of x? All right. So the given binomial expression is x raised to power minus 8 upon 3 plus x square log of x to the base 10 upon 8. This is the general your binomial expansion. So we know the general term in expansion of a plus x plus a raised to power n is given by tr plus 1 is equal to ncr x raised to power n minus r into a raised to power r. So you want to find out the sixth term, that will make t 5 plus 1, right? So that means n is 8, r is 5, x is x raised to power minus 8 by 3 whole raised to power n minus r, that is equal to 3. Multiply x square log x whole raised to power 5. Okay, this is given to you as 5600. So 5600 is equal to 8 factorial upon 5 factorial into 3 factorial into x raised to power minus 8 into x raised to power 10 into log of x raised to power 5. Okay, so this is 8 into 7 into 6 upon 6 into x raised to power 2 into log of x raised to power 5. Right? So let's do the cuttings. This will cancel. This will cancel at 100. So you have 100 is equal to x square into log x raised to power 5. So what can be done next? Let's pick up the options one by one. We have 6, 8, 9, 10 as the options. See, if I'm taking 6, let's try option 1. If I'm taking x is equal to 6, then this will become 100 should be equal to 36 log of 6 raised to power 5. You know, definitely this is going to be less than 100 because log of 6 is less than 1. Then definitely this whole term is going to be less than 100. That means this is incorrect. Second one, 8, which makes 100 should be equal to 8 square log of 8 raised to power 5. 8 square is 64 log of 8 raised to power 5. And this is also, see, log 10 is equal to 1 and less than a number less than that is definitely less than 1. So this is even not equal to 100. 9 will also be less than 100 only. I'll go with the 10th one only. 100 should be equal to 110 square log of 10 raised to power 5. You know, log of 10 is equal to 1. So this is equal to 100. That means option D is absolutely satisfying the question. And this is the answer to our problem. Hope you got that. Next is question number 25. How many terms are there in the expansion of this expression? So both are having the power of 4. Let's multiply them. You will get 3x minus 4 into x plus 3y whole raised to power 4. Now let's do the multiplication. You will get 3x square minus xy plus 9xy minus 3y square whole raised to power 4. This is equal to 3x square plus 8xy minus 3y square whole raised to power 4. So in this case, r is equal to 3 and n is equal to 4. Therefore, number of term in the expansion of this is given by required number of terms will be given by, you know, the formula. Actually, just let's write down the formula first. This is n plus r minus 1 c r minus 1. N in this case is 4, r is 3 minus 1, c 3 minus 1, 2. So this is equal to 6C2, which is 6 factorial upon 4 factorial into 2 factorial, which gives you 6 multiplied by 5 upon 2, that is 15. So we have option C as the correct answer. Hope you understood this. Let's move to the next question. Question number 26. P, Q, R, S are in AP such that P plus S is equal to 8, Q multiplied by R is equal to 15. Then the difference between the largest and the smallest numbers is. So you are given P, Q, R, and S. These are the 4 numbers which are in AP. So maybe write them like, I can write this like A minus 3D, A minus D, A plus D, and A plus 3D. Suppose we are assuming this. So first thing, it is given P plus S is equal to 8. So that means A minus 3D plus A plus 3D is equal to 8, which gives you 2A is equal to 8 or A is equal to 4. Second thing, Q multiply R is equal to 15. Q is equal to A minus D. R is A plus D. This is equal to 15. So this is equal to A square minus D square is equal to 15. A is 16. So A is 4. So 4 square is 16 minus 1 is equal to D square. So D's value will be equal to plus minus 1. So 2 values are possible for 3. So hence the number will be, if I'm taking the 4 numbers were A minus D, A plus, it's A minus 3D, A plus T, and A plus 3D. A was 4. So the 3 numbers, if I'm assuming this will be, I'm taking D as 1. Okay. So if D is taken as 1, that means this is 3. This is 0. No. 4 minus 3, that is equal to 1. This will be equal to A plus D. That is equal to 5. Sorry, I have done this mistake. These numbers are not like this. The numbers were A minus 3D, A minus T, A plus T, and A plus 3D. So if I'm taking D is equal to 1, the numbers will be 1, 3, 5, and 7. So next one, if I'm taking D is equal to minus 1, the numbers will be 7, 5, 3, 1. In any ways, the largest number of the AP is 7 and the smallest number is 1. And the difference between them is equal to 6. That means this is the correct answer for our question. Option A is the answer. Right? Next is question number 27. Consider the following statements for a fixed natural number n. CNR is greatest if n is equal to 2r. Second, CNR is greatest if n is equal to 2r minus 1 and n is equal to 2r plus 1. First thing, we know that when in C n minus r, n is even, greatest term will be NC n by 2. Here, n is equal to 2r in the first case. N is equal to 2r, which gives you r is equal to n by 2. That means CNR will be greatest when r is equal to n by 2, that is n is equal to 2r. So that means statement 1 is absolutely correct. Let's go with the second one. Second says CNR is greatest if n is equal to 2r minus 1. So we know this, that second statement, CNR will be greatest. I'm taking this when n is odd, will be greatest when n is odd. That is, either R will be n minus 1 or 2 by 2 or n plus 1 by 2. That is, n is equal to 2R plus 1 or n is equal to 2R minus 1. So that means this statement is also correct. This is valid for n is even and this one is valid for n is odd, which simply means that both 1 and 2 are correct. Option C is the correct answer. Hope you understood. Next is question number 28. It says m parallel lines cut n parallel lines, giving rise to 60 parallelograms. What is the value of m and n? So we are given m parallel lines and n parallel lines. They make together 60 parallelograms. So two lines from here and two lines from here will be taken. So the proper one, the required one will be MC2 into NC2. How many combinations are possible to make this? It makes 60 parallelograms in this case. So this will be m factorial upon 2 factorial into m minus 2 factorial multiply n factorial upon 2 factorial n minus 2 factorial is equal to 60, which makes it m into m minus 1 upon 2 plus n into n minus 1 upon 2 is equal to 60. Now, the given options, okay, what is the value of m plus n? So, if we take m is equal to 5 and n is equal to 4, if I take, see what we can do, this thing is equal to 160. So, now if I take m as 5 and n as 4, if we take m5 and n is 4, this equation will be 5 multiplied by 4 plus 4 multiplied by 3, which is equal to question number 28. It says m parallel lines cut n parallel lines to give rise to 60 parallelograms. So from the m parallel lines, I'll choose 2 lines, and from n also I'll choose 2 lines to make one pair of parallelogram. Similarly, choosing such lines, I got to have 60 parallelograms. Then what is the value of m plus n? Okay, so in this question, how many lines, how many ways are there in which two lines can be picked up from m parallel lines? It's given by MC2. Similarly, NC2 will represent in how many ways I can pick up two parallel lines from n parallel lines. Now, this gives rise to 60 parallelograms. This combination gives rise to 60 parallelograms, right? So this is m factorial upon 2 factorial into m minus 2 factorial multiply n factorial upon 2 factorial n minus 2 factorial is equal to 60, which gives m into m minus 1 upon 2 into n minus 1 upon 2 is equal to 60. Now you have to pick up a pair. There is no, because we have a single equation and two variables are there. We can't solve it from here. So we have to go for the hit and trial method only. Let's take, here comes a mathematics experience. If I take m is equal to 5 and n is equal to 4, let's fill. So this will be 5 multiply 4 into 3 upon 2 into 2. This should be equal to 60. In order for m to be, I'm just checking how much it comes. This comes out to be 60. That means this is true. M is equal to 5 and n is equal to 4. This is the correct one. Or you can say m is equal to 4 or n is equal to 5. Either one can be there. And there is no hard and fast rule for this. But we have to just find out the value of sum of them. In either case, the sum comes out to be 9. So we have option D as the correct answer. Hope you got this. Next is question number 29. It says, let X be the number of permutations of the word permutations and Y be the number of permutations of the word combinations. Which one of the following is correct? Okay, so let's write the word permutations. P, E, R, M, U, T, A. T is repeating. I, O, N, S. How many alphabets are there? 12. How many are repeating? But I mean, how many are coming twice? There is two alphabets, T and T, it's coming twice, right? So one alphabet actually is coming twice. So the number of permutations for the word permutations, you have to pay attention. S is there, so you can't miss any alphabet. Is given by 12 factorial, because the T is repeating itself, so it will be 12 factorial divided by 2 factorial. This is given to you as X. So X is equal to 12 factorial upon 2 factorial. Next, number of permutations. Let's write down combination first. Sorry for this. Okay, I missed it. No worries, I'll do it again. Permutations. You can skip the video. So the T is repeating itself here. Number of permutations in this case for permutation is given by 12 upon 2 factorial, which is actually X. So 12 upon 2 factorial. Next, number of permutations for the word combinations. Now the word is combinations. Let's write it down. C-O-M-B-I, combinations, B-I-N-A-T-I-O-N-S. O is repeating, right? O is also repeating. Okay. So 3 alphabets are repeating them. So in this case, number of permutations, how many alphabets are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Number of permutations for word combinations is 12 factorial upon 2 factorial into 2 factorial into 2 factorial, because these 3 alphabets were repeating themselves. This is equal to y. 12 upon 2 factorial is equal to x. You know this. So y is equal to x upon 4, or x is equal to 4y. This is the correct one. X is equal to 4y. Option C is the correct answer. Hope you got this. Let's move to the next question. Question number 30. 5-digit numbers are formed using the digits 0, 1, 2, 4, 5 without repetition. What is the percentage of numbers which are greater than 50,000? So in this question, first thing, you have to understand we are given 5 digits. You have to form 5-digit number, 5-digit numbers. 5 digits are given and you have to form 5 digits only. No repetition. And the number should be greater than 50,000. So these are the 3 conditions and the given numbers are 0, 1, 2, 4, 5. Pay attention, 3 is not there. These are the slight mistakes that you may easily do in the sum. So total number of ways in which 5-digit numbers can be formed from this. See, 1, 2, 3, 4, 5. I'm talking in general. I'm not considering this condition right now, right? What the total numbers that can be formed using these digits. Of course, I can't have 0 at this place because that will make it a 4-digit number. So, which means I can fill this place in 4 ways. This one also can be filled in 4 ways, 3 ways, 2 ways, 1 way. So the total number of ways in which it can be filled is 4 multiply 4, 3, 2, 1. 16, 6 are 96. So 96 ways are 96 numbers can be formed from these 5 digits to make a 5-digit number. Okay. Now the second, but now let's come to this condition. It says the number should be greater than 50,000. So total numbers, 5-digit numbers, greater than 50,000. Now this will be given by C, 1, 2, 3, 4, 5. This is of course got to be 5. I can't have any smaller number than this. So then this is 5. Of course, the next one can be filled in 4 ways. This one can be filled in 3 ways, 2 ways, and 1 way. This is of course 1 way. So the total number of ways are 1 into 4 into 3 into 2. That is 24. So the percentage of numbers which are greater than required percentage of numbers greater than 50,000 are 24 upon 96 into 100, which gives you 25%. All right, so this is the correct answer to the problem, option B. Hope you understood this. Let's move to the next question. Number 31. It says consider the following next para for the next 2 questions. Okay, next 31 and 32 questions will be based on this statement, which says let sine beta be the GM of sine alpha and cos alpha. GM, if this is a GM, then that means sine alpha into cos alpha is equal to sine square beta. Second, tan gamma is the AM between AM of sine alpha and cos alpha. So sine alpha plus cos alpha is equal to tan gamma. These are the 2 things which are given to us. We have to find out cos 2 beta. So cos 2 beta, all right. This can be written as 1 minus 2 sine square beta. Sine square beta is equal to sine alpha cos alpha. You know 1 is equal to sine square alpha plus cos square alpha. You know that. So sine square alpha plus cos square alpha minus, this was 2 missed. So 2 sine alpha cos alpha, which is actually equal to sine alpha minus cos alpha whole square, right? And this is present in the option sine alpha. Okay, this is actually can also be written as cos alpha minus sine alpha whole square. So we have option A as the correct answer. Hope that's clear. Easy question that was. Next is you have to find out the value. Same statement is there. You have to find out the value of secant 2 gamma. So secant 2 gamma actually is equal to 1 upon cos 2 gamma. You know one thing, cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. So let's fill in this one. You will have secant 2 gamma is equal to, this will go in the denominator. This whole thing will go in the denominator, and reciprocating that, you will get 1 plus tan square theta upon 1 minus tan square theta. This is secant 2, not sorry, theta gamma is upon 1 minus tan square gamma is equal to secant 2 gamma, right? Now we have tan gamma. We already knew in the last question. Tan gamma was equal to sine alpha plus cos alpha upon 2. So I'll fill in this question, which will make it, I'll pick it up this. So tan gamma, I'll not fill because this will be really jumbled because it's a huge expression. I'll simplify it first. So tan gamma is equal to sine alpha plus cos alpha upon 2. Let's do the squaring on both the sides. This is from statement. So you will have tan square gamma is equal to, I'm doing the square right away. You will have 1 plus 2 sine alpha cos alpha upon 4. You know, 2 sine alpha cos alpha is equal to 1 plus sine 2 alpha upon 4. You know this formula, sine 2a is equal to 2 sine a cos a, right? Okay. So now this further can be, I'll put this value in this equation. So secant 2 gamma, which was equal to 1 plus tan square gamma. So 1 plus sine 2x upon 4, 1 minus 1 plus sine 2x upon 4. This will be 4 plus 1 plus sine 2x, 4 plus, sorry, minus 1. 4 minus 1 minus sine, here was gamma. Question number 32. Same statement is there, but this time you have to find out the value of secant 2 gamma. Secant 2 gamma is equal to 1 upon cos 2 gamma, right? You know one thing, that cos 2 theta is equal to 1 minus tan square theta upon 1 plus tan square theta. So I'll fill in over here. You will have secant 2 gamma is equal to 1 plus tan square gamma 1 minus tan square gamma. Now let's take the help of this statement. It says tan gamma is the AM of sine alpha and cos alpha, which makes tangent of gamma is equal to sine alpha plus cos alpha by 2. Let's do the squaring on both the sides. You will have tan square gamma is equal to sine square gamma plus cos square gamma plus 2 sine alpha cos alpha whole divided by 4, which will make it 1 plus 2. See, 2 sine alpha cos alpha can be written as sine 2 alpha. You know this identity, right? Upon 2. Now let's fill in this thing, tan square gamma here. You will have secant 2 gamma is equal to 1 plus 2 sine 2 alpha upon 4 whole divided by 1 minus 1 plus sine 2 alpha by 4. This will be, you will solve it, 5 plus sine 2 alpha, 3 minus sine 2 alpha. Right. So this is the required value, secant 2 gamma. Let's check. We have option B as the correct answer. Hope you got that. Let's move to the next question, number 33. Okay, consider the following for the next two questions that follow. A flagstaff 20-meter long standing on a pillar 10-meter high subtends an angle of tan inverse 0.5 at a point P on the ground. Let T be the angle subtended by the pillar at this point P. Let's make a figure first for this problem. Then we will understand what we have to find out. Okay. So this is the figure. Now, a flagstaff 20-meter long standing on a pillar 10-meter high. So this is the pillar 10-meter high and a 20-meter flagstaff is standing on it. Okay, so this is the point B here. Let this be C and A. This is point P. Okay, fine. Now, according to the question, this is like this. So let theta be the angle subtended by the pillar at the point P. So this angle is theta, and I consider this angle as phi. Okay. So it's given that Flagstaff long standing on the pillar 10-meter high subtends an angle of this at the point P. So this phi is equal to tan inverse 0.5. That is actually equal to 1 by 2. Okay. So now this is a right angle triangle. So I'll be using my trigonometric ratios over here. Tangent of theta plus phi is equal to perpendicular upon base. So I'm taking the base as x. That is 30 upon x. So tan theta plus phi, let's open it up. You will have tangent of theta, tangent of phi upon 1 minus tangent theta, tangent phi is equal to 30 upon x. Now phi is given to you as tan inverse 0.5. That means it is equal to 1 by 2, which gives tan phi is equal to 1 by 2. Okay. And one more thing, if I'm taking the triangle ABP, let's do it here. In triangle ABP, tangent of theta is equal to 10 upon x. Now let's fill both of these value in equation 1. So filling values in equation 1, you will get 10 by x plus 1 by 2, 1 minus 10 by x into 1 by 2 is equal to 30 upon x, which gives you 2x upon 20 plus x whole divided by 2x minus 10 upon 2x is equal to 30 upon x, which makes 20 plus x upon 2x minus 10 is equal to 30 upon x. Let's do the cross multiplication. 20x plus x square is equal to 60x minus 300. X square minus 40x plus 300 is equal to 0. So let's do the splitting. X square minus 30 minus 10 is equal to 0, which gives you the two roots as minus 30, x minus 30. These are the two factors. X minus 10 is equal to 0. So the two roots will be 30 and 10. So x can be either 30 and 10. What we had to find out in the question was, okay, it says, it's asking in the question, if x is the distance of P from the pillar, then consider the following statements. X can take two values which are in the ratio 1:3. So x can take two values. We have found two values for x, and 30:10 or 10:30 is actually in the ratio 3:1 or 1:3. One of the same things. If I'm taking the two ratios, so that means statement 1 is true. Second one says you x can be equal to the height of the flagstaff. Here, x can't be equal to the length of the flagstaff because, see, x can equal to 10, x is equal to either 10 or 30. That means the flagstaff height was 20. That means this is not true. Statement 2 is wrong. Hence, only 1 is the correct answer, option A. Hope you got this. Let's move to the next question, number 34. So same question is there now. Okay, so in this question, we have to, the statement is same, which we used in the last question. Now the question is, what is a possible value of tangent of theta? So from using the above solution, we already had in the last question that tangent of theta was equal to 10 upon x. And we have the two values of x. X was equal to 10 or 30. So that means 1 or 1 by 3. right? So tangent theta can have the value as 1 or 1 by 3. 1 is not in the options, but 1 by 3 is available. So we have option C as the correct answer. Hope you understood this as well. Next is question number 35. So again, the same thing, 35 and 36 questions, they are going to use this same statement. It says the perimeter of the triangle ABC is 6 times the AM of sine of the angles of the triangle. Further, BC is equal to root 3 and AC is equal to 1. Let's make the triangle first. So this is the triangle A, B, and C. Now, you are given perimeter of the triangle ABC is 6 times the AM of sine of the all the angles. So according to the question, perimeter of, let's assume the three sides to be A, B, and C. It's given AC is equal to 1. So B is equal to 1 and BC is equal to root 3. So this is equal to this. I don't know about C. Nothing is given about C. Let's assume C to be X. All right. So the perimeter of the triangle, that means A plus B plus C is 6 times the AM of sine of the angles. So sine A plus sine B plus sine C whole divided by 3. This is like this. So A plus B plus C is equal to 2 sine A plus sine B plus sine C. Now by the sine rule, you have A upon sine A, or I'll write down sine A upon A. Sine B upon B, C upon C is equal to, let's say, some K. You know, A's value is root 3, B is 1, C, I don't know. Okay, I have taken that X, so I'll write down X over here. So this is equal to some K. So sine A is equal to root 3K, sine B is equal to K, and sine C is equal to X into K. So from this main equation, 1, filling all the values, let's fill in equation 1. You will have, this was A plus B plus C, that is 1 plus root 3 plus X is equal to 2 into root 3K plus this plus this. So 1 plus root 3 plus X plus 2K is equal to 1 plus root 3 plus X. This will give you K is equal to half. What we had to find out in the question, what is the perimeter of the triangle? So for that, I need to find out A, B, C, the three sides. I have already A, I have B, but I don't know what is C. So let's find out C. For that, I'll be using the Pythagoras theorem now. By Pythagoras theorem, AB square is equal to BC square plus AC square. How we can use the Pythagoras theorem, because we are not given that it's a 90-degree, it's a right angle triangle. But if you notice this thing, we got the value of K as 1 by 2. So let's keep it on a side for some time. Let's explain like why we can use this. You already had that sine A was equal to K into root 3. That means K came out to be 2. So this is equal to root 3 by 2, which is equal to sine 60, which makes angle A is equal to 60. Further, sine B was equal to K, which was 2, which is equal to sine 30, which makes B angle as 30. If A is 60, B is 30, then C is definitely going to be 90-degree angle. Okay, that is why I'm going to use this Pythagoras theorem over here. I hope you got this thing. It's a 90 degree. It's a right angle triangle at C vertex. So using the Pythagoras theorem, AB was equal to BC square plus AC square. So AB was equal to actually your X. So X square is equal to root 3 square plus 1 square, which is equal to 4. So X will be equal to plus minus 2. You can't have the negative value for the length. So X is definitely equal to 2. I hope you got this thing clear till here. See what we did in the question. I'm explaining it once again. You were given perimeter of the triangle was 6 times the AM of the sine of angles. So I have done perimeter of this triangle is equal to 6 times the AM of the sine of the angles, which gives you A plus B plus C is equal to sine 2 sine A plus sine B plus sine C. Now using the sine rule, I got that sine A is equal to root 3k, sine B is equal to k, sine C is equal to x into k. Fine. I filled it in the first equation, this one, to get the value of k, which came out to be half. When I got the value of k as half, I just saw that these two angles, sine A and sine B, they were equivalent to like giving me the angle A as 60 and B as 30, which definitely means the C angle is 90 degree, which helped me to apply the Pythagoras theorem and find out the value of x. Okay, now the whole sum can be stopped over here only. You need the perimeter A plus B plus C. We already knew A was equal to root 3. I think, yes, A was equal to root 3. B was equal to 1 and this is equal to 2. So 3 plus root 3 is the correct answer. Hope you got this. Option C is the correct one. Is that clear? Let's move to the next question, 36. Same statement will follow. Now I have another question. Consider the following statements. The first one says ABC is a right angle triangle. We just solved this in the last question itself. Yes, it is a right angle triangle. The angles of the triangle are in AP. Is that true? Let's see. So here the C was the greatest angle, which was equal to 90 degree. A was equal to 60 degree. B was 30 degree. Are the angles in AP? Let's see. So angle B plus angle C upon 2. This is equal to 90 plus 30 upon 2, which gives me 60. So yes, they are in AP. That means both A and B, option C is the correct answer. Both the statements 1 and 2 are correct. Hope you got this as well. Next is 37th question. Again, the same thing. This statement will be used in the next two questions. So time saver for you. That's x is equal to sine square A plus sine A plus 1 whole divided by sine A, where A lies between 0 and pi by 2. Okay. So let's write the statement. You have x is equal to, I'm taking the sine A common from here. So sine A plus 1 upon sine A. Now A lies in the first quadrant. It's given to us. Let's open it. You will have sine A plus 1 upon sine A. This is equal to x. Now we know that arithmetic mean is greater than or equal to geometric mean of any two numbers. That means this is okay. That means if I add both of them, arithmetic mean sine A plus 1 upon sine A whole divided by 2. Question number 37, consider the following for the next two items. That means 37 and 38 question are based on this statement. The statement is let x is equal to sine square A plus sine A plus 1 upon sine A, where A lies in the first quadrant. It lies between 0 to pi by 2. So A lies in the first quadrant. So here x is equal to sine A plus 1 upon sine A, or this is 1 plus sine A plus 1 upon sine A. Now you know one thing that for any two given numbers, the arithmetic mean is always greater than equal to geometric means. You always know for any two numbers, AM is always greater than equal to GM. If I take the two numbers as sine A and 1 upon sine A, so that will be sine A plus 1 upon sine A whole divided by 2 is always greater than equal to sine A into 1 upon sine A. So that means sine A plus 1 upon sine A is greater than equal to 2 always, right? So the minimum value for sine A plus 1 upon sine A will be 2, right? But your x was equal to 1 plus sine A upon plus 1 upon sine A, which means the minimum possible value for the given expression x is 3, right? So we have option C as the correct answer. Hope you understood this question. Let's move to the next question, number 38. Same statement is there. Now it says, at what value of A does X attain the minimum value? Now, what is the value of A for which X is minimum? In the previous question, we just solved that the minimum possible value for X was equal to 3. So that means 3 is equal to sine square A plus sine A plus 1 upon sine A, which gives you 3 sine A is equal to sine square A plus sine A plus 1. So this makes it sine square A plus 1 minus 2 sine A sine square A plus 1 minus 2 sine A is equal to 0, which is nothing but sine A minus 1 is equal to 0, which makes A is equal, sine A is equal to 1 by 2. 1, sorry, not 1 by 2, sorry. Sine A, which makes sine A is equal to 2. And you know, this is at 90-degree angle. So A is equal to pi by 2, for which X will be minimum. That means we have option D as the correct answer. Hope you got this. Let's move to the next question, number 39. So same thing, next two questions will be based on this statement. In a given triangle ABC, A square plus B square plus C square is equal to AC plus root 3 BC. Now you need to know what is the nature of the triangle. Is it equilateral, isosceles, right angle, scalene, but not right angle? Of course, if it's scalene, it's not got to be right angle. No, that's not, sorry. Okay, so given statement is A square plus B square plus C square is equal to AC plus root 3 DC. Now, there is, see, I can't solve. There are unlimited possible ways in which we can proceed with the sums to check. But the easiest one will be, we shall go with the each and every option one by one. If I check for the first one, if the triangle is equilateral. If the triangle is equilateral, you know, A is equal to B is equal to C. So this will be 3A square B square, sorry. Question number 39, again the same thing, 39 and 40 will be based on this statement. And the given statement is, in the triangle ABC, A square plus B square plus C square is equal to AC plus root of 3 BC. What is the nature of the triangle? Equilateral, isosceles, right angled, or scalene, but not right angled. Okay. Fine. So let's start with the sum. Instead of starting the statement, it's better, it's easier if I put in all the options one by one in the given statement and check for the validity. Equilateral triangle, you have A is equal to B is equal to C. So let's put in this. The first one will be equal to then A square plus A square plus A square is equal to A square plus root 3 A square, which makes 3A square is equal to 1 plus root 3 A square. That means 3 is equal to 1 by root 3, which is not true. So this is incorrect. Second one is isosceles triangle. Let A is equal to B. So this will be equal to A square plus C square plus AC plus root BC. So this will be 2A square plus C square is equal to C will be taken common, A plus root 3B. Okay, which is again incorrect. 2A squared plus C squared. This is not equal to this. So I can write here A only. This will be equal to AC 1 plus root 3, which is not true. That means B is also incorrect. Let's go for the third one, right angled triangle. If I'm taking a right angled triangle, let's assume the three angles to be, I can take any angles in this case. If I'm taking angle A to be 30, B to be 60, and C to be 90. One has to be 90 degree, and the rest two angles can be taken any random angles. Okay. Now the sides, if we talk about sides, we don't have a specific thing about them. You can also write down A upon sine A. Let's use the sine rule is equal to B upon sine B, C upon sine C. This is equal to, let's say, some K, which makes A is 30 degree. 30 degree is 1 by 2. So A upon 1 by 2 is equal to B of sine 60 degree is root 3 by 2 is equal to C upon 1 is equal to K, which makes A is equal to 1 by K by 2, B is equal to root 3 K by 2, and C is equal to K. These are the three sides. Now let's fill in over here in the given statement. A squared plus B squared plus C squared, which makes it K square will be taken common, 1 by 4 plus 3 by 4 plus 1 is equal to AC. So K square by 2 plus root 3 into BC, which is equal to root 3 by 2 into K into K. Okay. Yeah. So this will be equal to 1 by 2, 4 plus 4, 1 by 4 plus 3 by 4. This is 1 plus 1, 2. This is equal to K square by 2 plus 3 by 2 K square. This should be equal to actually, right? Here, LHS, I got 2K square, or on the right hand side also, I will get 2K square, which makes option C to be the valid one. That means this is the correct answer because the LHS and the RHS both matched. Both came out to be 2K square. That means we have option C as the correct answer. Hope you got that. Next is question number 40. Now it says if C is equal to 8, what is the area of the triangle? Let's draw the triangle. We already assumed the sides angles actually. So this was supposed to be 90. This is 60. This was angle B. Angle A was equal to 30. Okay. We assumed that only. Angle A we assumed to be 30. Yes. Okay. Next, what is the AC is given to you as 8? That means the hypotenuse is given to you as 8. Sine of 30 degree is equal to A upon, this is A, this is B, and this is C. So sine 30 degree is equal to A upon C. That means 1 by 2 is equal to this, which gives you the value of A as 4. Now, area of the triangle. For area of the triangle, you need AB. That means sine 60 also. Sine 60 will be given by B upon 8, that is C. Sine 60 is equal to root 3 by 2 is equal to B upon 8. So B comes out to be 4 root 3. Correct? What do we had to find out? Area of the triangle. Area of the triangle, half into base into height. Which is equal to 8 root 3 square units. So this is the correct answer to the question. Let's check. 8 root 3 is option C. Hope you understood this. Let's move to the next question. Question number 41, the same thing. 41 and 42 will be based on this given statement. Consider the function fx is equal to mod of x minus 2 plus 3 minus x, mod of 3 minus x plus mod of 4 minus x, where x belongs to the real numbers. At what value of x does the function have a minimum value? It's easier to solve the sum if I'll plot a graph for this. Let's go for the graph. Here is x and y. Y is actually equal to this fx. So if I take x is equal to 0, what will be the value of y? This will be mod of minus 2, 3, 4, which will be equal to 9. Okay. 1, 2, 3, 4, 5, and 6. So at x is equal to 1, y will be equal to minus 1 plus mod of 2 plus mod of 3, which will be equal to 6. X is equal to 2, y will be equal to 0 plus 1 plus 2, which is 3. Then x is equal to 3, y will be equal to 1 plus 0 plus 1, which is 2. Okay. And x is equal to 4. The value of y will be mod of 2 plus minus 1 plus 0, which is 3 again. So x is equal to 5. I need the statement. I put x is equal to 5. This will be 3 minus 2 minus 1. This is equal to 6. X is equal to 6. Y is equal to 4 plus 3 plus minus 3 actually. And here is minus 2, which is equal to 9. So you see one thing, when you will plot the graph for it, the y's value in the question, at what value of x does the function attain a minimum value? This is a decreasing function over here. And it came to 2. After this 2, it started increasing again. Right? First, it was decreasing. After 2, it started increasing. That means it is having the minimum value. It is attaining the minimum value for x is equal to 3. So this is the correct answer. Hope you got this. Next is question number 41. So same question. What is the value of the function? What is the value of the function? See, at x is equal to 3. F of 3, we actually calculated in the last question itself. It came out to be 2. Let's do it again over here for this question. So 3 minus 2 plus 3 minus 3, 4 minus 3, which is equal to 1 plus 1, that is 2. So option A is the correct answer. Hope that's clear. Next is question number 43. So this statement for 43 and 44 question, you have to consider the statement. Consider the sum s is equal to 0 factorial plus 1 factorial plus 2 till 100 factorial. If the sum s is divided by 8, what is the remainder? Okay, given sum, let's write it down. 0 factorial, 1, 2, till 100 factorial. So here, if you break it up, this can be written as 1 plus 1 plus 2 plus 6 plus 24 till, I'm not going to calculate 100 factorial over here. So this S1 plus 2 plus 6, I'll start taking into brackets, plus 24 till 100 factorial. So S can be taken as, here's, I missed a 2 over here. 1. Yes. So this is equal to 10 plus, I'll take 8 common from here. This will be 3 plus so on, 100 factorial divided by 8. Since rest each term, 24, 5 factorial, 6 factorial, 100 factorial is a multiple of 8. Let Question number 43, again the same thing. 43 and 44 questions will be based on this same statement. Let's write down the statement. It's a factorial problem. S is equal to 0 factorial plus 1 factorial plus 2 factorial, 3, 4 factorial, so on till 100 factorial. Let's open it. You can write S as equal to 0 factorial is written as 1 plus 1 plus 2 plus 6 plus 24, so on till 100 factorial. You can write it as 10 plus 24 plus so on till 100 factorial. Now I can take 8 common from here. This will be 3 plus something like 100 factorial. See over here 5 factorial divided by 8 upon 100 factorial divided by 8. Now, each of the terms, if I took this one, each of the term, that means which is 24, 5 factorial, 6 factorial and all that, they all are divisible by 8. So what if I put this whole thing, this whole bracket is divisible by, this whole bracket was divisible by 8 and I took 8 common from here. So you can write it as some k, right? So S will be equal to 10 plus some 8k. If now the question is, if the sum is divided by 8, what will be the remainder? Now, if I divide this sum by 8, you will have 10 by 8 plus 8k by 8, which will give you, here is 1 will come and the remainder in this case will be 2. This will give me a remainder of 2. And this will give me 0 remainder. So that means this whole expression when divided by 8 will give me a remainder of 2. And this is what we were looking for. Option C is the correct answer. Right? Next is question number 44. If the sum S is divided by 60, what is the remainder? Now I have to take my approach further using the same method which we used in the last one. In the last one, we came out to be S is equal to 1 plus 1 plus 2, 6, 24. Next is 5 factorial is 120. So see, I started getting a multiple of 60. Next is till 100 factorial. I'll do the same thing. Now this will be equal to 34 plus I'll take 60 common, 2, 100 divided by 100 factorial divided by 2. Okay. Yes. So now, from all the terms which are starting from 120 to 100 factorial, they are divisible by 60 for sure. Now, I will take this thing as k. So, the sum can be written as 34 plus 60k. If I divide this by 60, this will give me 0 remainder. And 34 by 60 is of course going to give me 34 remainder, which means option D is the correct answer. Hope you understood. Let's move to the next question. Question number 45. Consider the following for the next two questions. Let's read it. In a triangle PQR, P is the largest angle. Let's make it side by side. So here is the triangle PQR. It is said that P is the largest angle. Okay. Next, cos P is equal to 1 by 3. Further, the incircle of the triangle touches the side PQ, QR and RP at, okay, there's an incircle. Let's make the incircle first. This is the incircle. I'm not good at drawing actually. Okay, so this is the incircle. Now it touches the sides at, this is at N and this one at M and this one at L respectively. So let's name this side as P, this one as R and this one as Q, the length of the sides. Next, it is said such that the length PN, QL and RM. So it's given that NP is equal to N, QL is equal to N plus 2, and RM is equal to N plus 4 respectively, where N is an integer. Okay, so we have written everything which is given to us. Now, one more thing. Qn is equal to QL. You know this. We know this is the property of the in-circle. Also, Rn is equal to LR and Pn is equal to Pm. These sides are equal. Okay. Now, next thing, if NP is equal to N, then this is NP is also equal to, where it is, NP is equal to N. So if this is N, then MP is also equal to M, because these two sides are equal. Similarly, Qn is equal to N by 2 and LR is equal to N by 4, right? Now, if I write down QR, QR is QL plus LR, which gives you, this is equal to whole P, small p, and this is QL is equal to N plus 2, LR is equal to N plus 4, which is equal to 2N plus 6. Second one, QP is equal to small r. So QP is equal to QN plus NP. This is equal to N plus 2 plus N, which gives you 2N plus 2. So we got these two values. Now cos P is equal to Q square plus R square minus P square upon 2QR. This is given to you 1 by 3. So this is 2N plus 1 whole square plus 2N plus 2 whole square minus 2N plus 6 whole square. I hope you know how did I calculate Q. See, this is equal to Q. Q is equal to MR plus PM. This is equal to N plus 4 plus N, which gives you 2N plus 4. Okay. This whole divided by 2 into 2N plus 2 into 2N plus 4. Let's open up the numerator. 1 by 3 is equal to 4n square plus 16 plus 16n. 4n square plus 4 plus 8n minus 36 minus 24n minus 4n square. Whole divided by, I'm taking 2 common from this. So I'll be left with 8 into n plus 1 into n plus 2. This will, on doing all the cuttings and everything, 1 by 3, you will get 4n square minus 16 upon 8 into n square plus 3n plus 2. Let's do the cross multiplication. You will have here n square plus 3n plus 2 is equal to, this will cancel. Actually, I'll take 4 common from here and this will cancel. So this will be 3 by 2 n square minus 4. So n square plus 3n 2n square plus 6n plus 4 is equal to 3n square minus 12, which will give 5 n square minus 6n minus 16 is equal to 0. The two factors will be minus 8 plus 2. So the two factors will be n minus 8, n plus 2. That means n can have two values as 8n minus 2. Right? So over here, n can't be negative because it relates to the length. That means n is equal to 8 and option C is the correct answer. Hope you got this. Next is question number 46. So same thing, same question, same statement is there. Now you have to find out what is the length of the smallest side. So from here, see, if you look at the last question, it was since PQ was equal to NP plus QN, which was equal to 2n plus 2. In the last one, we got n is equal to 8, so this makes it 18. Next one was QR. QR was equal to QL plus LR, which was equal to 2n plus 6, that is equal to 16 plus 6, 22. Last one, RP was equal to RM plus MP, which was equal to 2n plus 4, which makes it 16 plus 4, that is 20. So, of course, the smallest side is PQ, that is 18. And we have option D as the correct answer. Hope you got this. Let's move to the next question then. Question number 47. You have to consider 47 and 48 questions for this statement. Now it says sin x plus cos x plus tan x plus cot x. Let's write it down. I'll directly open up it. Okay. So sin x, cos x, tan x can be written as sin upon cos plus cos upon sin plus 1 upon cos 1 upon sin is equal to 7. So I'll not touch the first two terms. I'll write down sin x plus cos x. So here will be, see, sin square x plus cos square x. This will be 1 upon sin x cos x upon sin x plus cos x upon sin x cos x is equal to 1. Now let's put sin x plus cos x is equal to t. Let's do the squaring on both the sides. You will have sin square x plus cos square x, which will be 1 plus 2 sin x cos x is equal to t square, which makes 2 sin x cos x is equal to t square minus 1, or sin x cos x is equal to t square minus 1 upon t. Now let's get back to our statement, equation 1. From 1, you have, see, sin x plus cos x, this was equal to t. This is equal to 1 upon t square minus 1 upon 2 plus t upon t square minus 1 upon 2 is equal to 7. So here was plus. So this will be t plus 2 upon t square minus 1 plus 2t upon t square minus 1 is equal to 7, which makes it t square minus 1. So this will be equal to, I'll not touch t because this will make it t cube. I don't want that to happen. So this will be 2, 1 plus t is equal to 7. So t into this can be t plus 1 into t minus 1. That will cancel. You will be having 2 upon t minus 1 is equal to 7. Right? Now, this will be t square minus t plus 2 is equal to 7t minus 7. Right? I had done the I have taken the LCM. At the same time, I have done the cross multiplication. So this will be t square minus 8t plus 9 is equal to 0. So the two factors will be, see, over here, now I'll fill in the value for t only. Okay. T was assumed to be sin x plus cos x, and t square was 1 plus sin 2x, 2 sin x cos x. I'll fill in the value. I will not find out the factors now. So this was equal to 1 plus 2 sin x cos x square. It was this minus 8 into sin x plus cos x plus 9 is equal to 0. Now this is equal to 1 plus sin 2x. This is equal to, I'll keep 9 with it. And this is 8 sin x plus cos x, which makes it 10 plus sin 2x is equal to 8 sin x plus cos x. Now let's Do the squaring on both the sides. You will have squaring on both the sides. You will get 100 plus sine square 2x plus 20 sine 2x is equal to 64 sine square plus cos square. So this is 1 plus sine 2 sine x cos x will be equal to sine 2x only. I hope you got this step. So sine square 2x, 64 will be taken on the right hand side, left hand side. So you will have minus 44 sine 2x plus 100 minus 64 will give you 36. This is equal to 0. So this is the required equation. Let's check with the option. Sine square 2x minus 44 sine 2x plus 36 is option A. So this is the correct answer to our problem. Hope you understood. Next is question number 48. Same statement is there which we have done, and now the question is a bit different. Now the question says if sine 2x is equal to A minus b root c, where a and b are natural numbers and c is a prime number, then what is the value of a minus b plus 2c? Now from the previous question, you had sine square 2x minus 44 sine 2x plus 36 is equal to 0. So the value of sine 2x is equal to 44 plus, see I'm taking using the quadratic formula, minus b plus minus root of b square minus 4ac upon 2a. So this is equal to 44 plus minus 44 square minus 4 into 36 whole divided by 2. This is plus minus. Okay. So sine 2x is equal to 44 plus minus, when you will solve this, you will get 1792 in the root divided by 2. This is equal to 44 plus minus 16 root 7 divided by 2, 22 plus minus 8 root 7. Now it comparing with this one, which is a minus b root c. A minus b root c. Let's do the comparison. So you got what you need to find out in the question. A minus b plus 2c is equal to. Okay. So from here, you get a is equal to 22. B is 8 and C is 7. So A minus B, sorry, we had to find out the value of A minus B plus 2C. 22 minus 8 plus 14, this will give you 28. All right. So this is the answer to the question. Option D is the correct answer. Hope you got that. Let's move to the next question, number 49. It says you have to see 49 and 50. They are using the same statement. Quadratic equation is given by this. You have to find out the harmonic mean of the roots of the equation. So if I assume alpha and beta to be the roots of the equation, you know the sum of the roots is given by minus the coefficient of x upon coefficient of x square. So this will be given by, in this case, minus minus will cancel. So 4 plus 2 root 3 divided by 3 plus 2 root 2. Now, product of the roots, that's given by c upon a, that is the constant, which is 8 plus 4 root 3 upon a, that is 3 plus 2 root 2. Now, harmonic mean is given by 2 into product of the two numbers divided by the sum of the two numbers. Product of the two numbers was equal to this, whole divided by 3 plus 2 root 2. This whole is divided by 4 plus 2 root 3. This is multiplied by 2. 3 plus 2 root 2. So these two will cancel and you will have 8 plus 4 root 3 whole multiplied by 2 upon, I'll take 2 common here from here, 2 plus root 3, and this will cancel out. Okay. You will have 8 plus root 3. I'll do one thing. I'll take 4 common from here as well. So 4 will be taken common. 2 plus root 3 upon 2 plus root 3. They will cancel out and I will have 4 as the answer. Simple as that. Option B is the correct one. Hope you understood. Next is question number 50. Now you have to find out GM, geometric mean of the roots. So to find out the GM, you know the formula, it's root of the product of the two numbers for which you have to find out the GM. GM is equal to root of the product of the two numbers, which are actually the roots of this equation. Alpha into beta, in the last question we did, it was equal to 8 plus 4 root 3 upon 3 plus 2 root 2. I'll take 2 common from the numerator. So this will be 4 plus 2 root 3 upon 3 plus 2 root 2. Okay. So this is equal to further right. So now question number 50, it's the same statement. Now you have to find out the GM of the two roots. GM is given by root of the product of the two numbers, which are in this case, in this question, they are the roots of this equation. Alpha into beta, in the last question, we just found out that was equal to 8 plus 4 root 3 whole divided by 2 root 2. This can be written, I'll be taking 2 common from the numerator. So this will be 4 plus 2 root 3 upon 3 plus 2 root 2. 2 into, this can be written as 1 plus 2 plus 2 root 3. Actually, 3 can be written as root of 3 square. Whole divided by 3 can be written as 1 plus root 2 square plus 2 root 2. I hope you're getting what I'm trying to do over here. I have split up this 4 into 1 into 3, 1 plus 3, and 3 can be written as root 3 square. Similarly, I have split this 3 as 1 plus 2. 2 can be written as under root 2 square. Now this makes root of 2. The numerator will become 1 plus root 3 whole square. And the denominator will become 1 plus root 2 whole square. That will give you under root 2 into 1 plus root 3, 1 plus root 2. Let's rationalize the denominator. So you will have here, okay, or 1 minus root 2, whatever suits you, that will be okay as well. So this will be equal to root 2 into root 6 minus root 3 plus root 2 minus 11 whole divided by 2 square minus 1 square, which will give you 1. Okay, so this becomes root 2 outside, root 6 minus root 3 plus root 2 minus 1. So this is option, let's check the options. We have option A as the answer. Hope you understood this. Let's move to the next question then. So students, before moving to the next question number 51, here's a quick reminder to visit our website www.examsnet.com. There you will find not only this, but a number of other similar type of entrance exam question papers, which will help you to prepare even better for your exams. You can also download our app. The link is available in the description box. So let's start with question number 51. 51 and 52 questions will be based on this same statement. It says, let the determinant, this matrix is given by this, determinant is given by this. And it's in the very first 51st question, it's given if the determinant is equal to 0 for every alpha greater than 0, then which one of the following is correct? All right. So it is given that this determinant is 0 for every alpha greater than 0. So let's take alpha is equal to 1. Let's start with this only. So if I'm taking alpha is equal to 1, let's put it in the determinant. You will have A, B, C, D is equal to A, B, A alpha, that is 1, plus B, B, C, B plus C, and A plus B, B plus C, and 0. Now let's do some expansions. I will do some operation on the first column. I'll be transforming into C1 plus T2. Now this is given to be 0. So C1, adding the two columns and placing it in C1. So this will be A plus B, B plus C, and A plus 2B plus C. And here is B, C, B plus C, A plus B, B plus C, and 0. This is equal to 0. Now let's do another transformation, which is C1 is to C2. C1 is to C1 minus C3. So after this, you will get it as 0, 0, A plus 2B plus C, B, C, B plus C, and A plus B, B plus C, 0. Now let's do the expansion through the column 1. This will give you that the determinant is equal to A plus 2B plus C whole multiplied by B square plus BC minus AC minus BC. These two will cancel. A plus 2B plus C, B square minus AC. So this is given to you as 0. So that means either B square is equal to AC or A plus 2B is equal to C, 0. A plus 2B plus C is equal to 0. So looking at this clearly shows that A, B, C are in GP, which means we have option B as the correct answer. Hope you got that. Next is question number 52. So same statement is there. Now it is saying if the determinant of A, B, C values are given to you and alpha is unknown, this is equal to 0, then alpha is root of which of these equations. So basically what you have to do is you have to find out the value of alpha, and then I will check whether it satisfies which of these following equations, right? Let's write it down. So delta 7, 4, 2 alpha is given by 7, 4, 7 alpha plus 4, 4, 2, 4 alpha plus 2, 7 alpha plus 4, 4 alpha plus 2, and 0. This is equal to 0. Now let's do the expansion of it. Expanding. Let's find out the determinant. You will say this will be 7 multiply 0 minus 4 alpha plus 2 square plus 4 alpha plus 2, 7 alpha plus 4 plus 7 alpha plus 4, 16 alpha plus 8 minus 14 alpha minus 8. So let's solve it. You will have 7 minus 7 brackets minus 16 alpha square minus 4 minus 16 alpha plus 4 into 28 alpha square plus 16 alpha plus 14 alpha plus 8 plus 7 alpha plus 4 into 2 alpha is equal to 0, which on solving will give you minus 112 alpha square minus 28 minus 112 alpha plus 112 alpha square plus 120 alpha plus 32 plus 14 alpha square plus 8 alpha is equal to 0, which will, like you will do all the solvings, these two will cancel, and further doing all the cancellations, you will have 14 alpha square, and this will give you minus 112 minus this and this. So this will give you 16 alpha plus 28 and 32 minus 28 plus 32 will give you plus 4 is equal to 0, which gives you 7 alpha square is plus 8 alpha plus 2 is equal to 0. So we got the equation actually. So alpha is the root of this equation, right? That means alpha is root of 7x square, 8x plus 2 is equal to 0, which is option C, right? Hope you got this. Let's move to the next question, number 53. Question number 53. Consider the following statement for the next question number 53 and 54. Given the statement is m of theta is given by this expression where n is a fixed positive real number. Then what is the least value of m theta? See, to answer such type of questions, generally we take the way of the method of using the AM and GM concept. You know, the arithmetic mean of any two numbers is always greater than equal to the geometric mean between those two numbers, right? So I'll be using the same concept in this question. First of all, m theta is equal to cot square theta plus n square, tan square theta plus 2n. Now I'll pick up, just leave it. I'll pick up these two terms, n cot square theta and n square tan square theta. You know, the AM is always greater than equal to the GM. Let's find out the arithmetic mean of it. So cot square theta plus n square cot square theta upon 2 is greater than equal to root of cot square theta into n square tan square theta. You know, these two will cancel out and you will have cot square theta plus n square tan square theta is greater than equal to 2n. All right. So that means the least value of this whole expression is 2n. Least value of cot square theta plus n square tan square theta is equal to 2n. But what was m theta? It was equal to cot square theta plus n square tan square theta plus 2n. So I'll add plus 2n also on this side. So the least value of this expression, that is 4n. The least value of the given expression, that is m theta, is 4n, and option D is the correct answer. Hope you got this. Let's move to the next question, number 54. So same statement is there. Now it's asking you under what condition does m contain the least value. So you have to find out what is the condition. See, theta and I have two things over here. N is there and theta is there. And in all of these options, there is showing a relationship between n and theta. This, out of these four options, which condition will satisfy for m to have the least value? Okay, so you know one thing, m is going to have the least value, cot square theta, this is m, plus n square theta, n square tan square theta plus 2n. The least value for this is 4n. So this can be written as cot square theta plus n square tan square theta minus 2n is equal to 0, right? Or this can be written as n square tangent of theta, tangent square theta minus 2n plus this is equal to 0. So let's, using the quadratic formula, let's find out the value of n using quadratic formula. So n will be given by minus of b, that is plus 2 now, plus minus b square, which is minus 2 square, that is 4, minus 4 into a, which is tan square theta, into c, cot square theta, upon 2a, that is 2 tan square theta. So this will be 4 minus 4, this will be left like 0. You will have 2 upon 2 tan square theta, which gives you cot square theta. So that means M is going to have the least value when n is equal to cot square theta. Option B is the correct answer. Hope you understood this. Then let's move to the next question. Next is question number 55. It says consider the following statement for the next 55 and 56 sums. Statement is a quadrilateral is formed by the lines x is equal to 0, y is equal to 0, x plus y is equal to 1, and 6 plus y is equal to 3. Okay. So, this is the line. The y-axis is actually the line. X is equal to 0. And x-axis is the line where y is equal to 0. This one is the line. This particular one is the line x plus y is equal to 0. And this line represents 6x plus y is equal to 3. Now, I have named the coordinates. This is OABC. OABC is the required quadrilateral, which is talked about over here. Now, what is the question? What is the equation of the diagonal through the origin? This is the origin and the coordinates. Let's write down the coordinates of all ABC, OABC now. This is origin. O is at origin. That means the coordinates are 0, 0. This is the line, this particular one. This is the line x plus y is equal to 1. So if I put x is equal to 0, y is got to be 1. So that means the coordinates are 0, 1. Here the coordinates of C are similarly 1, 0. No, C's coordinates are not 1, 0, sorry. C's coordinates will be, this is the line 6x plus y is equal to 3. So if I'm putting x is equal to 1 by 2, then y will be equal to 0. So if here is y is equal to 0, then x is got to be 1 by 2. So the coordinates of C are 1 by 2 comma 0. And let's talk about the coordinates of B. Now B is actually the point of intersection of lines x plus y is equal to 1 and 6x plus y is equal to 3. So let's solve it simultaneously. I'm subtracting these two. You will have 5x is equal to 2 or x is equal to 2 by 5. If I'm putting x is equal to 2 by 5, the value of y will be 3 by 5. Okay, so the coordinates of B are 2 by 5 and 3 by 5. We got all the coordinates. Let's write down them once. O is having the coordinates 0, 0. A is having the coordinates 0, 1. B is having the coordinates 2, 2 by 5, 3 by 5. And C is having the coordinates 1 by 2, 0. So we have done all the initial preparation to solve the sum. Now let's get to the basic sum. What was it? It's asking what is the equation of the diagonal through the origin. So basically you want to find out the equation for the line OB. See, we know the 2 points, coordinates for the 2 points. It's very easy. We can frame the equation. So required equation, it's OB. Required equation is the equation of OB. So equation of OB will be given by, y minus, I'm taking this point, 0. And these are the 2 points which will be considered is equal to, let's find out the slope. So the slope will be given by y1 minus y2 upon x1 minus x2 into x minus 0, which will give you 3 by 2x or 3x minus 2y is equal to 0. This is the required equation. 3x minus 2y is equal to 0. This is option C. Hope you got this. Next is question number 56. Same statement. Now you have to frame the equation for the other diagonal. The other diagonal, if you rewind the video and see, the other diagonal is AC. And the coordinates of A were 0, 1 and C were this. So the required equation, same method, required equation will be given by y minus 1. I'm considering this point is equal to 0 minus 1 upon 1 by 2 minus 0 x minus 0. So y minus 1 is equal to minus 2x, or y plus 2x minus 1 is equal to 0, or 2x plus y minus 1 is equal to 0. 2x plus y minus 1 is equal to 0 is option D. Hope you understood. Let's move to the next question. Question number 57. Consider the following for the next two sums, 57 and 58. It says Pxy is any point on this ellipse. Let E and F be the foci of the ellipse. Then you have to find out what is PE plus PF. Actually, this is quite an easy sum. So you are given this ellipse. Okay. I'm not good at drawing, so I just want you to understand the concept. So if this is the ellipse, right? These are the two foci. Let's name this as E and F. And let this be the any point P, X, Y, which is talked about in the sum. You know one thing. Okay, first of all, let's write down the ellipse. It is x squared plus 4y squared, which can be written as y square upon 1 upon 2 square. This is equal to 1. So here A is 1 and B is equal to 1 by 2. You know the property of the ellipse. It says that sum of distance of any point on the ellipse is from the foci. Focus is equal to 2A. Okay, so that means PE upon PF is equal to 2. Okay, so we have option B as the answer. Hope you understood. Let's move to the next question, number 58. So same sum is there. Now the question is, which of above point lies on the latest rectum of the ellipse? So if this is the ellipse, this is the first E and F. Now it is asking you which of the above points lies on the latest rectum. Let's talk about the latest rectum. What is the equation of latest rectum? It's plus minus AE. What is E? It's given by 1 minus B square upon A square. So in this case, B is equal to 1 by 2. So 1 by 2 square is 1 by 4 upon 1. This is equal to root 3 by 4 or root 3 by 2. So that means equation of latest rectum will be x is equal to plus minus root 3 by 2. Right? So if I denote it over here, this is the latest rectum, L dash. This is the latest rectum. So if I check, see all these, x is equal to this line means y can have any value, but x has got to be 3, either plus 3 by 2 or minus root 3 by 2, which is satisfied by all the 3 points. We are not bothered for anything for the value of y. It can have any value. Only x should be either plus root by 3, root 3 by 2 or minus root 3 by 2. So that means 1, 2 and 3. All of these points lie on this latest rectum. Option D is the correct answer. Hope you got this. Then let's move to the next. Question number 59. So same question, 5960 will be following the same statement. The line Y is equal to X partitions this circle in 2 segments. Let's draw the circle. Okay. Let this be the axis. Now, if I look at this one, then this circle, and what is the center of the circle? A comma 0, right? So this is, if I take A point over here, A comma 0 is somewhere over here. This is the center of the circle. So this is got to be the circle. The radius of the circle is A. Right? Now, the line y is equal to x. What is, let's draw a line y is equal to x. It's got to be more precise. So this is the line y is equal to x. Let's name this point as A. This is the origin, and this be the point B. I'm naming it as O also because this is the center, and let's draw perpendicular like this. Okay. Now, what is the area of the minor segment? That is basically you have to find out this area. This is the area of the minor segment. You know one thing, area. Now, this is a segment, right? Area of minor segment will be given by area of this quadrant O dash BA. Area of quadrant O dash BA minus area of triangle OAB. All right. Now, what is the area of this quadrant O dash BA? This is pi r square, where r is the radius, upon 4 minus half into base into height for the triangle. Area, radius in this case was A. So pi A square upon 4 minus half into base is equal to A and height is also A. So half into A square as well. This will give you A square by 2 pi by 2 minus 1. Yeah. So let's check with the options. Okay, I have everything denominator 4. So this can be written as A square into pi minus 2 upon 4. A square into pi minus 2 upon 4 is option A. Hope you got that. Right? Next is question number 60. Now, what is the area of the major segment? You got the area of the minor segment. It's easy to find out the area of the major segment. Same thing will be there. Area of major segment. Now, I'll be considering the whole circle. Area of major segment is equal to area of circle minus area of minor segment. Right? What is area of the circle? Pi a square. Area of the minor segment in the last question we found out that is a square pi minus 2 upon 4. So this will be 4 pi a square minus pi a square plus 2 upon 4, which will give you 3 pi a square plus 2 upon 4. So I think we got our answer. Sorry, here I missed a square. So this is, let's take a square common, 3 pi plus 2 upon 4. Right? That is option B. Hope you got this. Let's move to the next question then. Question number 51. Same thing, 61 and 62 questions will be based on this statement. It says let A is this let A is this coordinates and B has these coordinates be the endpoints of the diameter of this sphere. Now the question is, what is U plus V plus W is equal to? So basically, to answer the question, you need to find out the values of U, V and W. And how we can do that? First thing, if this is the given sphere A and B, this is having the coordinates as 1, minus 1, 2, and B is having the coordinates 2, 1, and minus 1. AB is the diameter, right? So if AB is the diameter, what is the center? You know, center will lie in the mid. So that means it is equal to 2 plus 1, that's 3 by 2, minus 1 plus 1, 0, 2 minus 1 upon 2, that is this, using the midpoint formula. Okay. Now, let's go to the radius. You know, radius is half the length of the diameter. That is AB. Diameter is AB, so that means this is half of AB is equal to 1 minus 2 minus 1 square, which is 1 square, plus minus 1 square, which is minus 2 square, plus 2 minus 1, minus of minus 1, which is equal to 2 plus 1 square, which will be half of root of 1 square plus 4 plus 9, that is equal to 14, root 14 by 2. This is, we got the center, we got the radius. Now, let's frame the equation of the sphere. Now, equation of sphere will be given by x minus 3 by 2 square plus y minus 0 square, z minus 1 by 2 square is equal to root 14 by 2 square, which will give you x square minus 3x plus 9 by 4 plus y square plus z square minus z plus 1 by 4 is equal to 14 by 4. So this will give you x square plus y square plus z square minus 3x minus z. Over here, this is z by 4. So this is 14 by 4 minus 9 by 4 minus 1 by 4, which will give you 4 by 4, that is equal to 1. Okay, so the equation becomes x square plus y square z square minus 3x minus z minus 1 is equal to 0. Now let's compare it with the given equation, which was x square plus y square plus z square plus 2ux vy plus 2wz minus 1 is equal to 0. So these two match, match. So from here, u's value is equal to minus 3 by 2. And v is got to be 0 because there is no coefficient of y available. And z is equal to, not z, sorry, w is equal to minus 1 by 2. Okay. Right. So simply you have to find out u plus v plus w, that will be equal to minus 2. Hope you got this. Let's see, we have option A as the correct answer. Right? Next is question number 62. So same question, now the question, same statement. Now the question is, if p, x, y be any point on the sphere, then what is the value of p a square plus p b square? See, this is the sphere. It said that a is one coordinate and b is another point for the diameter. This is the one. Here is p. This is the point P. Now, you know one thing, diameter of any circle, in this case, I'm taking as part of it. So anything, this subtends the angle of 90 degree, which makes PAB a right angled triangle. That means AB square is equal to PA square plus PB square. This is something I want to find out, right? What is AB square? We just, in the last question, we calculated AB was equal to root of 14. So root of 14 square is PA square plus PP square, which gives you answer as 14. So we have option B as the correct answer. Hope you got this. Then let's move to the next question number 63. So now same thing, 63 odd question, 63 and 64, they are going to have the same statement. Let's read. Consider two lines whose direction cosines are this, and they are inclined at an angle of pi by 4. What is the value of k? Let's write down the given direction cosines. A is 2 minus 1, 2, and V, for V, this is K, 3, 5. Now they are inclined at an angle of pi by 4. Therefore, then cos theta, this is given by A dot P upon modulus of them. So, see, this is equal to 2k minus 3 plus 10 upon. This is given by 4, 2 square plus 1 square plus 2 square, which is 4 plus 4, 1 plus 4, multiplied by root of k square plus 9 plus 25. This is cos pi by 4. Cos pi by 4, that is cos 45 degrees, 1 by root 2. This is equal to 2k minus 3 plus 10, 3 multiplied to 34k square. Okay, so let's do the cross multiplication. So 3, here was plus, sorry. 3 multiply 34 plus k square is equal to root 2 into 2k plus 7. Let's do squaring on both the sides. You will have 9k square plus 34 is equal to 2k plus 7 square. Let's open it. So 9k square plus 306. This will be equal to 2 into 4k square plus 49 plus 28k. 9k square plus 306 is equal to 8k square plus 56 k plus 98. K square minus 56k plus 208 is equal to 0. Let's split the middle term. You will get k square. The two factors are 52k and 4k plus 208 is equal to 0. K minus 52 minus 4k minus 52. So the two factors are k minus 4 and 52. That means k can have the value of 4 or 52. So these are the two possible values for k. Let's see. 52 is not on the options, but 4 is definitely there. So option A is the correct answer. Hope you understood. Next is same statement. Now the question is, what are the direction ratios of a line which are perpendicular to both the lines? Okay. So given the 2 points, given the two direction ratios were A was 2 minus 1, 2 and B was k 3, 5. We actually found out the value for k, so let's write down that only. 4, 3 and 5. Now the direction ratios of a line which is perpendicular to both the lines. Direction ratio of the line which is perpendicular to both the lines. This is given by I, j, k, 2 minus 1, 2, 4, 3, 5, which can be written as I into minus 5 minus 6, j, 8 minus 10, k, 6 plus 4, which is equal to minus 11i minus 2j plus 10k. So the direction ratios, see, this also can be written as 11i plus 2j minus 10k. Right? So the direction ratios will be 11, 2 and minus 10. Let's check with the options. 11, 2 minus 10. This is option D. So option D is the correct answer to the problem. Hope you understood this. Let's move to the next question. Question number 65. So 65 and 66 questions will be using this statement now. It says let A vector is this, C vector is this. Let